You've probably heard the buzz, right? About maybe another planet way out there, hiding beyond Pluto.
It's definitely caught people's attention. And what's really interesting is where the idea is coming from. It's not exactly new observations.
Right. It's digging into older stuff. We're talking findings from analyzing historical data.
Yeah, from the infrared astronomical satellite IRAS and also the Japanese Echo-I satellite.
And this data goes back quite a way, doesn't it? Like 1986 to 2006.
That's the range, yes. So it's a case of potentially finding something hidden in archives, you know?
So for you listening in and wanting to get up to speed, that's what we're doing today. A real deep dive into what astronomers might have found lurking in that old data.
Okay, so first off, how is this thing even detected? Because it wasn't someone just spotting a new dot of light through a telescope.
Right. So how did they pick up on it?
Well, the first clues were these kind of unexplained, anomalous patterns, things acting weirdly way out in the Kuiper belt, beyond Neptune.
Acting weirdly how? Like gravitational nudges or something.
Exactly. Think of it like seeing unexpected ripples on a pond. You know something's causing them, even if you don't see the pebble drop. These patterns suggested a pretty significant unseen mass was influencing things.
Ah, so those gravitational clues told them where to look in the old infrared data.
Precisely. They looked at the archives from IRS and Akari, searching for faint heat signals in the right area, and they found a candidate object that appeared in images from both satellites, but at different times.
Okay, finding it twice, years apart. That's important. It means it's not just like sensor noise or a distant galaxy, right? It moved.
That movement is absolutely key. But because it's in old data, it also means we desperately need new observations. We need to track it properly now, confirm its actual path, its orbit.
Got it. So based on those subtle patterns and the faint heat signals they found, what are they suggesting this thing is actually like?
Well, the data points to it being very, very far away. The estimated distance is somewhere between, let's see, 46.5 billion and 65.1 billion miles from the sun.
Whoa. Okay, just for comparison, Pluto's around 4 billion miles out, give or take. So this is like 10, maybe 15 times further.
Easily. It's way out there in the cold dark.
And at that kind of distance, how long would it take to go around the sun? Its year must be huge.
Incredibly long. The estimates are somewhere between 10,000 and 20,000 Earth years for just one orbit.
10 to 20,000 years. That's hard to even wrap your head around.
It really is.
What about its size? What kind of object are we talking about?
The estimated mass is, well, pretty hefty, between 7 and maybe 17 times the mass of Earth.
7 to 17 Earth masses. That's significant.
Very. And that mass, combined with the likely temperature out there, probably around minus 200 degrees Celsius and what it's likely made of, it points strongly towards it being an ice giant.
Nice giant. Like
Yeah.
Uranus or Neptune.
Exactly like that type, yeah. Just potentially bigger and obviously much, much colder and further away.
Okay, so a massive frozen world hinted at by these gravitational ripples and faint old heat signals. This brings us to the big question, though. What does it take to actually call this thing a planet, especially when it's based on indirect evidence and old data?
Right, and this is where the careful science comes in. It's not official yet. To be called a planet by the International Astronomical Union, the IAU, it has to tick specific boxes, meet clear criteria.
Which are what again? I always forget the details after the Pluto thing.
Yeah. Okay, first, it has to orbit the sun. The movement seen between the IRAS and Akari images supports this, but we need to confirm the full orbit.
Makes sense. What's next?
Second, it needs enough mass for its own gravity to pull it into a roughly spherical shape. Hydrostatic equilibrium, basically.
And something 7 to 17 times Earth's mass would definitely do that.
Oh, absolutely. No question there.
And the third one, the one that got Pluto.
That's the tricky one. It must have cleared the neighborhood around its orbit.
Meaning its gravity dominates its path. It's swept up or kicked out most other stuff.
Exactly. And proving that for an object so far out in a region like the Kuiper belt that's full of icy bodies, well, that's a major challenge. That's a big part of the ongoing verification.
So confirming the orbit, and especially confirming it meets that cleared orbit rule way out there, that's the crucial next step.
That's it. It needs dedicated observation campaigns with our most powerful telescopes now that we have a potential place to look.
So why should you, listening at home, care about this? I mean, beyond just cool, another planet maybe? What's the deeper significance?
Well, because if it is confirmed, it really does change our picture of our own solar system,
I
fundamentally.
think so.
It suggests there could be major players out there we just didn't know about. components that influence the structure of the outer solar system, the Kuiper Belt objects, maybe even explain other weird things we've seen. It literally redraws the map of our cosmic backyard.
So it's not just adding a dot, it's potentially revising the whole model. Yeah. Okay, let's quickly recap this deep dive then. Researchers looked at old infrared data from the IRA's and Akari satellites, spurred on by some odd patterns in the Kuiper Belt.
And they found faint heat signals hinting at a possible ninth planet, way beyond Neptune and Pluto.
This potential world seems to be a large ice giant, maybe 7 to 17 times Earth's mass, incredibly far out, taking maybe 10,000 to 20,000 years to orbit the sun.
But, and this is the key takeaway right now, it's still potential. It needs confirmation.
Hmm.
Rigorous follow-up observations are essential to lock down its orbit and see if it truly meets all the criteria to be called a planet.
Especially that cleared orbit rule.
Especially that one. It's a great example of how science works, an exciting hint followed by the hard work of verification.
And it's just a powerful reminder, isn't it? That even close to home, cosmically speaking, there are still huge unknowns, big mysteries potentially hiding just out of view, or even buried in data we already collected.
Absolutely. Makes you wonder what else is out there.
It really does. Well, that's been our deep dive for today. If you found this journey to the outer solar system interesting, definitely give us a like. It helps us know what you enjoy.
And subscribe so you don't miss our next exploration.
Yeah, and please let us know in the comments. What other scientific mysteries, discoveries, or research papers do you want us to dive into next time? We're always looking for ideas from you.